side do you want? Which side do you want me to? Which side?
Okay. Hello, everyone, and welcome to our talk today, which is called Vector Workflows, about making razor-sharp assets. My name is Nick Butcher, or Crafty. I'm a developer advocate on the Google Android team, and I specialize in UI development, and I'm a bit of a vector fanatic. And I'm joined today.
Hi, I'm Alex. I'm a software engineer at Lyft. I work on design systems there.
Great. And the slides for this talk are actually already online. You can find them here, so if you're following along on the video recording, don't worry about having to zoom in or pause or stuff. You can get the slides with all the motion and videos and stuff as well. So the goal of this talk today is that all of you should be embracing and using vector assets in your applications today. I'm convinced that they're the way forward, and today I want you to know everything that our combined knowledge about vectors, transmit it all to you, so you know everything you need to know to use vectors successfully in your applications. The reason why I think vectors are important is because the realities of deving for Android right now is that devices come in all sizes and shapes, and more importantly, in all kinds of screen densities. That's why, but unfortunately, until now, until recently, we normally provide assets in a raster or bitmap format, which kind of bakes in a resolution. Which is why we're used to this kind of thing, having to provide multiple versions of essentially the same asset in order that it looks good on different screen densities, right? And the reason I've had this diagram kind of flowing off to the side of the screen is that the trend is only for ever more dense displays. Maybe this will stop at some point, but it's annoying, right, when a new density comes out, having to basically re-export the same asset in a different density just to make sure it doesn't look terrible. So vector assets, on the other hand, don't have this issue. Rather than baking in that resolution into the kind of file itself, they instead kind of describe the contents of the drawing, and as such, they can be re-rendered on an arbitrary canvas density. So you only need a single file in order to support all devices. And to summarize it, I'd say that vectors really have these three main benefits. Firstly, they are sharp. So because they are infinitely scalable, because they describe their contents, that you'll never see issues like this. So the reason we have to provide those multiple versions of raster assets is that they don't rescale gracefully. If you have an asset and you blow it up, you get scaling artifacts like this, which look pretty terrible and basically make your assets look fuzzy. Vectors don't suffer from this. You can scale them to any size. They're generally pretty small. The vector formats are text-based, so they kind of compress down very, very well. And as we said, you only normally have to include one version rather than multiple versions of ever increasingly larger densities. So they can add up to significant size savings in your applications, which is great for download times, updates, and things like that. The file names here are made up, but the size savings are real from an update I did to the Google I/O app a couple of years back, where we switched from raster assets to vectors, and got some pretty good savings for not just for free, but for better fidelity, because they're going to be crisp at every single density. And the last benefit I see is that they're, I've called it animatable here, but this is kind of burying the lead a bit. Because they don't basically discard the information and flatten it down into this raster format, because it kind of describes the contents of the drawable, you can do cool things at runtime. So you can do things like animate the paths, move them around, or you can do things like have them change based on states and so on. So because this information is preserved, it opens up new possibilities for much more flexible assets. So you can do things that you just can't do with raster assets like tinting and so on. So that, you might say, that all sounds great. Why now? Why haven't we had this all along? And it really comes down to, as everything in software engineering, a trade-off, really. To think about it, let's look at how an asset goes from in your application onto the screen. So for a vector asset, we essentially, when you kind of load it into your app code, we essentially have to hydrate that model, take the definition that you give it, so you author them in kind of an XML format, which gets built into a binary format. But at runtime, that gets inflated into kind of model classes, and then those model classes execute essentially canvas commands in order to draw. Rather than doing this every single time, for a static vector, we'll cache that. We'll actually draw that to a bitmap so that subsequent draws are extremely efficient. Compare that to a raster format like bitmap or pings, then all we had to do is to decode that into a bitmap and then just draw. So essentially, you kind of offload this kind of like drawing commands onto your host machine. So you do them, in Photoshop or whatever, and output like a rendered asset. So, it's going to be a bit more efficient to do that. So back in the day when Android was kind of young, then, devices were relatively much less powerful, and there were relatively fewer screen densities out there. And as such, it made sense to support the raster formats, because we didn't want to take that hit of at runtime inflating and drawing, and there weren't many densities to think about. The times have changed. I think now the variety of devices out there and the relatively much more powerful devices that we have flip this equation, I think. And now the flexibility that vector assets give you, I think, are much more desirable. So as such, this is why I think now is the time that pretty much all your normal kind of application assets should be thinking about vectors. So when you think about vector formats, you inevitably end up finding SVG, scalable vector graphics, which is the de facto vector standard on the web and graphics packages and so forth. But if you look into the SVG spec, you see it supports a phenomenal amount of things. It's actually a pretty old spec. It's been around for a long time, and the support has kind of like grown pretty organically. You can do stuff like this, which is it applies like a blur filter to some shapes and then applies like a color mask in order to kind of change the color. So you can do these like really, really kind of rich graphical things like natively in the SVG format. You can embed animated GIFs within an SVG. You can execute arbitrary JavaScript within an SVG. So basically what I'm saying is a lot of these features in SVG just don't make sense on a constrained mobile device like an Android phone. So as such, this is the reason why we didn't want to natively support SVG in the platform. We do, however, like parts of the SVG spec, one of which is the path data spec, which essentially is a specification for how to draw any arbitrary shape. It defines like basically very primitive drawing commands like draw a box, draw a circle, draw this polygon with these points. And that is essentially what we did adopt and bring into the Android platform, plus a few Android-specific features as well. So let's take a look at what vector drawable can do.
Okay, cool. So that's SVG. Vector drawables. What are they? How do you create them? So if you've never seen one before, this is what they look like. Similar to SVG, they are declared in an XML format. It's a tree-based structure of XML nodes. Each vector has a root tag, vector tag. You specify an intrinsic width, in this case 48 dp. This is basically the size that the vector would be if you were to set it on an image view that declared wrap content for its layout width and height. On the other hand, the viewport width is, as you can see, it's not declared as a dimension. It's just a float value. And what this is it's essentially the virtual canvas in which the vector is being drawn into. So as you can see, all of the coordinates in this path data string are declared in terms of this 24 by 24 canvas. And this is essentially where vector drawables density independence comes from, right? Like everything's being drawn in terms of 24 by 24, so it can be scaled arbitrarily without losing any information. Here's what, just a closer look at what this path data spec even means. I remember the first time I saw this, and it was just a bunch of random letters to me, and it made no sense. But the way I like to think about it is it's essentially a pen floating on top of a virtual canvas. So the M command stands for move to. So I'm going to move the pen to coordinate 6.4, 6.4. Then I'm going to draw a line to a new endpoint. I'm going to lift the pen up, and I'm going to draw another line. And I've just created a cool little cross icon. And there are many different commands in the path data spec. Here are some of them. There are commands to draw curves. There are commands to draw arcs. There's a close path command that will close the current contour that you're drawing. There are even more in addition to these. And when you think about it, you can sort of create any arbitrary shape with some sort of combination of these commands, right? Like you can sort of think of it as the Adobe Illustrator pen tool or something. Like any shape can be drawn using some combination of these. And I don't go over this because I think that you should be fluent in this and like you should be able to preview vectors in your mind and immediately know what this shape is. No one can do that, but I think it's important because it will make life easier when we're dealing with animation techniques, specifically path morphing. So paths by themselves don't actually do anything. You need to specify either a fill color, in this case, just a hex color 999. This is how you would draw a border around a shape, or a fill color, which describes how the interior of a closed shape should be drawn. In addition to paths, there are these things called groups, which allow you to define arbitrary transformations on one or more paths, or one or more groups of paths. When you think about it, this may not seem super useful because technically this information could have been baked right into the path, and you might think like, why is there a need for these arbitrary transformations? And the reason why is because it'll become really useful later on when we talk about animated vector drawables. You can animate these properties as you would with the view property animator, or the view's scale X or translate Y property. There are also something called clip paths, and a clip path is it's similar to a path. It defines a region in which pixels should be drawn. So if you have a path and you want to say, I only want this region of that path to be drawn, you could use a clip path to define that region. To give sort of an example of why you might want to not use these too liberally, here's an example of a camera shutter icon drawn two different ways. The one on the left is drawn just using 6 separate paths. So I'm drawing 6 separate, wedge-shaped paths. On the right, I'm drawing a opaque rectangle that just fills the entire viewport, and then I'm defining a clip path that says, I only want, these 6 wedges to be drawn. And the reason why I say this shouldn't be used too liberally is because as you can see, if you blow up this icon, clip paths on Android aren't anti-aliased. So I think this is sort of like a recurring theme that there are multiple ways to do something with vectors. Some are better than others. And so you can also trim stroked paths. And I'll just give a really quick example of what I mean by that. Say you have a unit length path. And by default, the trim path start and trim path end properties are 0 and 1 respectively. But say you only want to draw the first 3/4 of a path. You can do that by setting the trim path end to 0.75, and that tells the vector to only draw the first 3/4 of the path. Similarly, you can increase the size of the trim path start to start the path a little bit later to even further reduce its visibility. And lastly, you can use a third property called trim path offset that will just shift the path over. And one cool thing to note about this is that if you shift it over enough, it'll eventually wrap around. So this is also kind of a useful technique to be aware of when you're writing something like a loading spinner animation or something like that. So similar to views, vectors have an alpha property. You can define, for example, in this case, I want this vector to be drawn at 70% opacity. You can also tint them, and in this case, I'm tinting this icon with color control normal. And this is useful because if you're not aware, color control normal is the default icon color used by AppCompat, and this is useful not only for to keep the colors of your icons consistent, but in cases where you want to have a dark mode icon and a light mode icon, right? This will allow you to define a single vector that will support both light mode and dark modes. So by tinting using theme attributes, you can avoid having duplicate vectors when the only difference is the color that it's being drawn in. Speaking of theme attributes, you can also set theme attributes as the vector's fill color, and this is also has similar advantages. Like, for example, say that you have an icon like this, and the only difference is the color of the jersey. Well, what you can do is you can create a theme overlay like this, and using the Android:theme attribute on a view, you can extend your theme with a different value for color primary. And by doing this, you can, at runtime, when it's inflated, it will take on different fill colors depending on the theme that you give it. I should also mention that this is something that Android Studio might warn you about using theme attributes in your vector drawables. I forget if that bug was fixed, but if it does, you should ignore it, because one of the cool things about vector drawable compat is that in order to backport it on KitKat and below, what the support library will do is it'll read the vector as plain text. It'll actually go through the XML as plain text, and it will extract that information. So whereas if you were to inflate it using the normal Android resources mechanism, you'd get a crash on KitKat, but if you use vector drawable compat, which you probably should always be doing, you'll get this theme attribute support for free.
Cool. So more stuff vector support. So far we've looked at static colors, be they hard-coded or defined as theme attributes. But you can also define color state lists. So in this trivial example, we're having the heart change color when it's pressed. So to do that, you refer to a color state list as you would elsewhere, using the @color reference, and then have another file in your colors directory which defines the different colors per state. This can be pretty handy if you have something like this, where we have a list view type situation, where we want this drawable on the left to be only slightly different if it's in a, say, selected state. So you can ship this as a single asset rather than having to have multiple assets which are 99% the same, except for some color around the edge. Another advanced feature of vectors is they support gradients. So we support 3 different types of gradient. There's a linear gradient, which you define as this. So you have to give the definition of the start XY and end XY and start and end colors, and it will do a gradient between those colors. We support radial gradients, which take a center point and a gradient radius. And the last type we support is a sweep gradient, which just takes a center point and does a sweep around from that color, one color to the other. Those examples I showed use a shorthand syntax where we define just the start and end color, or you can actually specify a center color. But there's also a format you can use like this, where you can embed child tags within the gradient to give arbitrary color stops. So you can go, gradient through multiple colors. And you do that by defining this offset property, which is essentially the percentage of the way through the gradient you want to change color. So gradients can be pretty handy when you're doing things like this. So this is an example of an adaptive icon I made. And gradient vectors unfortunately don't support drop shadows or blur effects or anything like that. But you can fake it with gradients. So in this icon, we're doing a lot of gradients. So the central triangle will have linear gradients on it to give it an element of a lighting model, a bit of depth to it. But we're also faking this long shadow effect with this linear gradient going across the diagonal, as well as the drop shadow, faking it again with a linear gradient. The background is a radial gradient, giving that outer glow. But also these circles with a sort of drop shadow beneath them are faking it again by drawing a white circle on top of a radial gradient. So you can see if you're building something like this, it's great to be able to use a vector asset, so this will, again, remain crisp on all densities, and you can use things like gradients to work around some of the limitations of the format, like lack of shadow support. Gradients also support a couple of cool features, one of which is tiling. So if you define the gradient so that it doesn't fill the entire shape that you're going to draw it on, you can specify how that gradient should behave. The first one is repeat, so it just goes repeats, like going from one color to color B, color 1 to color 2, whatever. The second one is mirror, so it goes from color 1 to 2 to 1 to 2. Or the default behavior is clamp, so just continue at the end color. And just because gradients it's a gradient. It doesn't actually have to kind of go through multiple colors. You can use a trick like this, where you specify coinciding color stops. So here I've got 2 stops at 50% of the way in order to get these color blocks. And then you can combine that with something like the tile mode in order to create like rudimentary pattern support. So in this example here, I'm just defining the gradient over this kind of like highlighted square in the top left. And then the tile mode of repeat takes care of repeating that pattern. And so it fills the entire shape with this kind of like pattern, which can be quite useful. So for example, this is a single shape, which I'm filling with a repeated gradient using this kind of coinciding color stops. And then, because it's a vector, I can grab that path and animate it. So going back to what Alex said about the size and the viewport, the viewport defines the size that you can draw in, but it's not contained by it. By which I mean, here we're using the viewport is like 360 wide, but you can actually, in your path data, specify drawing commands outside of that. So in this example, what I'm doing is saying if that is the entire viewport, say 360 virtual pixels wide, I actually define the shape to be drawn as wider than the viewport, such that I can then animate it back through, and the viewport will kind of clip it so you just see that window into it. So you can animate the shape back kind of like 2 stripes worth, and then reset it, and then animate it, and then reset it, and then animate it. And you can do fun things like this. So this is a lack of slides. Hello? I think my animation was too cool for the projector. Slide gods, can you help us?
It's coming, I think.
They're waving and shaking their hands, which means you all get a break. Oh. Is that a let's unplug it and plug it in again? That's how you fix everything, right? Hey! It's cool. I'll send you a link. Yeah, you can do cool stuff with it. So how do we actually use these vectors in our application? Vector drawable was introduced in Lollipop API 21. So if you're 21 plus, then you're good. So yeah, the vector drawable class, and also its animated cousin, animated vector drawable. But as Alex alluded to earlier on, there's actually a very capable backport in Jetpack. So you can use vector drawable compat and animated vector drawable compat all the way back to 16 or whatever the min SDK of Jetpack is these days. So I would actually recommend you always use the compat library, because that allows us to ship some bug fixes and actual feature enhancements back to older platforms. So for example, some new features were added to vector drawable in API 24, Nougat, but we added them to vector drawable compat. So by always using the compat library, you get to use those new features not just on 24, but all the way back to 16. And if new features were to be added to Vector and we were to backport them, if you're already using the backport library, the Jetpack library, then you'll just get access to them straight away, rather than using the platform library and then maybe switching later. To use the backport, we recommend you use the app-compat resources path. So to do that, you can use the source compat attribute on image views. So that essentially, instead of using source on image view, you use source compat, and that plugs into the backport path. And a new addition to app-compat 1.1.0, which is currently in alpha but should be going stable hopefully soon, is we've just added compound drawable support. So you can do drawable left compat, top, start, whatever compat on app-compat text views as well. And a small shout out, we also added drawable tinting. So some of the tinting stuff we talked about that you can do directly in the vector, you can also do at the view level if it makes more sense for your application to do it there. If you're not using it in image views or text views and other places that you want to use the backport, the way you do that is use this app-compat resources class and call getDrawable from it. So don't use context compat or anything getDrawable. Always use app-compat resources if you want to use the vector backport.
Cool. So to be clear, always use vector drawable compat, right?
Yes.
Even if you're min SDK 21.
Yes.
Cool.
Even min SDK Q.
Yeah. Yeah. And another reason why it's really important to do that is because some OEMs didn't implement the path data spec properly on 21 and 22, I believe, and it will just crash if you try to use the framework version. So aside from backporting features, it's also useful to use the compat support library implementation just for the sake of not crashing on your users when you inflate a drawable.
Wait, so should I use the platform vectors, or?
I think you should use the compat.
Have you got it?
Yes. Okay, cool. That's actually the most common question I get at Lyft. Okay, so we talked about how vectors are a subset of SVG, so the natural question is, how do you convert them? So you start with an SVG, how do you get to a vector drawable? And this has kind of like historically been the most difficult part about vector drawables. For a while, Android Studio wasn't great. People relied on third-party tools to do a lot of the converting, but I'm really happy to say now that Android Studio is actually like amazing at converting vectors now, and you should probably always use it. And
that's coming from someone who's written a converter.
Yes, don't use my converter. I think I deprecated all mine. But yeah, so to get to this wizard, you go under File, New, and then Vector Asset or something like that. But something Nick told me about literally this weekend is a really cool feature in, what is it, 3.4?
Yeah.
Android Studio. Yeah, so there's this new thing called the Resource Manager, which is basically a window into resources for your Gradle modules. And a really cool feature about this is you can drag and drop your SVGs into this window, and it will batch convert them for you. And as you can see, Nick, I guess, just converted 3 Oreos to vector drawable. I'll play that again. It's at the top left, I guess. You just drag and drop it into there, and you should be done. It's pretty awesome, and I think I'm going to use that a lot.
And there's a whole talk about this later on today
yeah.
at Makers.
If you want to, for some reason, like integrate this conversion in your CI, for example, I have a blog post at j.mp/svg2vector, and that basically describes how to build the converter from source in AOSP, and you can use it as a command line tool. It's what I use to batch convert all the vectors at Lyft. So speaking of conversion, who should own it? Should it be design or development? Ideally, kind of in an ideal world, I would say designers should own this because they also provide PNGs. They provide assets for iOS developers. It would make sense for them to own it. Unfortunately, we live in a world, I think, where development kind of has to own it because most designers don't have Android Studio installed. They don't know how to confirm that it actually displays properly. So the question is, how can we kind of work around this to make life as easy as possible given this limitation? So now I'm going to go over a couple of tips for exporting SVGs. So the first one is kind of intuitively prefer simple filled stroked shapes. So for example, if you're drawing something like this, don't draw a circle and then layer another white circle on top of it. Just use a circle with a border. And aside from making this more efficient, it kind of just makes sense that the simpler your shape, the less likely it will be that your SVG converts properly. So another tip is to flatten your shapes. So at the top, you can see this little flatten button. This Android is drawn using multiple shapes, and what I can do is I can just select this body thing and flatten it, and boom, I've just reduced the amount of paths in my SVG by 3. Another tip, always export artboards. If you select the shape and you try to export it, you're going to lose that padding, so it's really important to export the entire artboard. Select the artboard and then go under this menu and export it. One last tip, try to avoid masks when possible. Sketch has this feature called masks, which aren't entirely supported by vector drawable, so it's best to, instead of using masks, to use Boolean operations like this. So here, instead of using a mask, I'm using an intersection Boolean operation, which will translate over to a clip path in a vector drawable. And lastly, tell your designers to install this plugin. SVGO is a command line tool that will auto-optimize all your SVGs, and this will run every time you export an SVG in Sketch. So if you have this installed, you'll get your SVGs optimized, and it will be much more likely for them to convert properly. You can even customize these settings if you need to. The config file looks something like this. You can find it at j.mp/svgo-config. This is what I use at Lyft to convert or to optimize our icons before I attempt to convert them. It has a few more settings enabled that work really well for simple icons. Here's a little demo of what that process looks like. You can see that once I've exported it, it gives me a nice little message how much stuff I've saved. SVGO is also available in the browser using a cool tool that Jake Archibald from Google made called SVG OMG. It has a nice little panel where you can enable and disable certain plugins and see the results of how your SVG is being optimized. And lastly, if your designer is using Illustrator, tell them to export using the SVG Tiny 1.2 spec. This is a spec that's trimmed down and only supports a limited set of SVG that translates really well over to vector. So definitely use that when possible.
Cool. So I said you should be mostly using vector assets in your applications, but that was a little bit of a generalization. Like, when should you use them? Firstly, the SVG spec, like the vector spec, because it describes the paths of what you're drawing, it's great for doing things like simple icons, like this avatar thing on the right, but it's horrible for doing things like a photograph, right? You wouldn't want to describe each and every kind of region which you have to fit in. So don't think it's a magic bullet. You're not going to replace all assets if it's something like photographic data. But the thing is that these two extremes are pretty clear, right? Don't use it for photos, use it for simple icons, got it. But what about if you're somewhere in between, like, the world is grayscales? We provide a bit of loose guidance in this, in that we, on our documentation, say, think about using a vector for assets smaller than 200 by 200 dips, or there's a lint warning which will shout at you if you put a path in which is greater than 800 characters. And the reason for it is this. If we were to think back to earlier in the talk where we talked about the process that the vectors have to do, is they have to inflate. They have to basically go through this definition and read it and then inflate model objects and then execute canvas drawing commands before anything can go on screen. So as such, there is a loading cost to vectors. So each of those things, the size that you're drawing is going to increase the drawing time, as well as the number of and complexity of the path commands is going to massively increase the inflation time. But I believe in a rule of tools, not rules. So while we give you these kind of helpful mnemonics, there's actually some tracing data added to vector drawable which you can use to determine whether or not a particular vector is problematic. So the way you do this is you use systrace, and you look out for these tags which will tell you how long a vector drawable took to both inflate and to draw, which you can see in here. So as an example of this, a developer got in touch with me saying they had this icon, an adaptive icon in their application, and they were getting this shouty warning, and they were wondering, is this a problem? Do I need to change something in my vector? Should I go back to using a raster asset? And I looked at it and it's this is a perfect candidate for a vector. But I took a look at it in Android Studio to see what was going on, and it was pretty complex. So if you look at the shape here, firstly, there's a huge number of paths going on here. There's 71 separate paths and 34 different groups. And if you look at it, in the gutter on the left-hand side, on Android Studio, it shows the colors, and you can hopefully see there's a load of colors being shown there. But this icon is only kind of blue and white, so what's going on there? And if I comment it out, if you comment out one of the paths, you can actually see there's some colors underneath, but it's completely obscured by something on top of it, which is kind of redundant. And lastly, if you look at this, each of these rectangles has one of these group elements around it that we talked about being somewhat redundant in a static vector, but useful for animation. So this is kind of we're doing work, we're doing another canvas operation to translate, to draw each of these shapes, which you just don't need to do. So I set about trying to optimize this. I only had the vector drawable to start with, so I used Alex's tool, Shapeshifter, which we'll get to convert it back into SVG, because SVG actually has a lot richer tooling for editing. There's no editors that I know of that let you edit a vector drawable natively. Then in Sketch, I took a look at it, and I kind of hand optimized some stuff, so I removed anything that was completely obscured. And then I ran it through that tool we just talked about, SVG Optimizer, which did some things I wasn't expecting. So, for example, there was lots of white blocks, and then there was some white text on the blue. And SVGO actually said, oh, that's all white, I'll merge those all together. Because a path doesn't have to be continuous. You can have lots of multiple closed shapes. So you can use one path to represent all of the blocks and the text. I then ran that resulting SVG back through Android Studio's converter to turn it into a vector drawable. And the resulting shape was this. So we're down from 71 paths and 34 groups down to 2 paths. And was it worth it? So I profiled this on a pixel with locked CPUs and ran it a few thousand times and took some averages. And looking at those systrace tags, the original version was taking around almost 11 milliseconds to inflate and just under 2 milliseconds to draw. And the optimized version was down to 3.6-ish milliseconds to inflate and half a millisecond to draw. So you can see quite big improvements for zero cost. This is a zero cost thing because it's the exact same rendering output. And you might say, shouldn't the system be smarter? Those things were obscured. You shouldn't have drawn them at all. Well, we can't just ignore information because we don't know if you're going to animate something later. Maybe you're going to run an animation over this vector and reveal that colored information behind. So the tooling can't, at design time, be smart enough to infer that information. So it's on you. It's kind of like you give us garbage in, you'll get garbage out. So it's worth the time to understand some of the limitations of the spec and the tooling available to help you optimize it in order to produce more optimal results. Another issue I see with using vectors is it's very easy to introduce something that isn't supported in the format. So, for example, someone asked me about converting an SVG of this lovely, delicious-looking Oreo cookie. But when we ran it through the Android Studio converter, it produced this huge file. It was 116K, and it actually wouldn't load. It fell over trying to parse the path when you tried to load it at runtime. And the reason is, if we zoom in, the designer had used this lovely texture, which is so easy to do when you're an illustrator. Just apply a textured brush and you get these little shapes. But simple decisions like that can have a massive knock-on effect down the line to our assets. So the problem is that these this. Hopefully it comes out in the video. This noise texture pattern along the Oreo looks really nice when you zoom in like this, but to represent that in an SVG is actually just huge. It had to convert each of those little texture points to an individual path, and so there's just tons and tons and tons and tons of data. So what I did is I got the SVG and I just removed the texture, and at the size we were working at, it didn't really make a huge difference. I then ran that through SVGO and converted it down to a vector drawable, and it was down from 116K to 760 bytes. So it's what I'm saying is, it's not a magic bullet. Vectors, if you give it something that isn't natively supported in the format, it's going to have a hard time doing it for you. So knowing something about the format, what it supports, helps you to make intelligent decisions, maybe push back to your designers and say, hey, this isn't supported. Is it okay if we don't use a texture? It doesn't really make a huge difference to the size we're showing this image or whatever at. And the resulting SVG was like this. It was teeny tiny. Should we go quickly through this? I think we're about to run out of time. But one of my favorite things about vectors is because it doesn't discard this information, you can do things like animations. So here's some animations which I wrote in an application called Plaid, so they're all open source. You can see all these. And what I was talking about before is that because the paths are individually addressable, they're still maintained, the information, you can attach an animator or animator set to each of those and do interesting things. So that's essentially what the animated vector drawable format is. It's a very lightweight file that just says, I want to take this vector and run these animations on these paths. I'm going to skip this, because I talked about it a lot yesterday. So essentially, you can animate everything we just looked at, basically. So you can do cool things like, we looked at that trim about how you don't have to draw the entirety of a path. So we can do something like this, where you're just trimming the bottom legs of the X to turn it into this down arrow. Or you can do something like this magnifying glass turning into a back arrow, which is just a number of paths, overlaid in red here is the complete path, and just by setting trim values, we can only draw a subset of it, and animating those trim values gets you this nice effect. Or you can do something like this, where I'm animating when the heart breaks in half, I'm doing a rotation and changing the opacity to get this breaking effect. Or you can do things like animating the actual path itself, which is, in here, we're animating either the path of the plus minus or the clip path, which is actually controlling what's drawn on the eye in order to get this strike-through effect, to cut out the section of it. So I think path morphing is actually probably one of the most interesting properties that animated vector drawable can do, and you made it even easier.
Yes, also the most complicated, and I have 30 seconds. But it is also my favorite thing to talk about. So path morphing. Here are 6 path morphing animations. As you can see, unlike when you're animating the translation or a scale or something numeric, path morphing is animating the object's actual shape. You can create even more complicated things like this, when you're just morphing arbitrary animals together. There was definitely a time when I looked at this and I thought, how does this magic happen? So how you would do it with an animated vector drawable, you're animating 2 path data strings. And this might seem a little bit confusing at first, and a lot of times if you attempt to do this, you'll get an exception. And that's because of a requirement that Android enforces on us, that paths must have the same number and type of drawing commands. And we'll see why that's an important requirement to satisfy. Say you have a square and you want to morph it into another square. Well, this is pretty easy. You just morph the coordinates, like 6, 6 goes to 4, 4, 18, 6 goes to 24, etc. And essentially what you'll have is the paths just following a straight line during the animation into their new state. But now say you have a square and you want to morph it into a circle. You'll probably express that circle as 2 arcs like this, and now you suddenly don't know how to animate between these 2 states, right? Like you can't animate a line into an arc in a way that Android will be able to automatically understand. But what we can do to satisfy this requirement that both shapes have to have the same number of points and types of drawing commands is we can do tricks, like we can convert those arcs into cubic Bezier curves, and then we can convert those lines into cubic Bezier curves that they're being drawn with curve commands, but they look like lines. And once you do this, you have something that can be morphed from one state to another, and you won't get that crash anymore. And you can even go further with this by defining even more points to even further control what the animation will look like at runtime. So obviously, that's a lot to take in, and that's not super trivial to do. Like, you don't want to be converting cubic Bezier curves or into arcs or whatever by hand, because you're going to have a hard time. And that was sort of the motivation behind a tool that Rebecca mentioned yesterday, and I think Juhani mentioned earlier today, called Shapeshifter. And what I'm going to do is just go through a really short example, since I'm basically out of time, that morphs a arrow into an overflow icon. And in order to do this, I'm going to use Shapeshifter to copy these 2 SVGs into the program. And I'm going to copy the end state into the 2 value, and I'm going to edit the path morphing animation. And what I'm going to do is I'm going to first, I don't have the right number of shapes. Like, I'm morphing 1 shape into 3 shapes, so I'm going to split up that arrow by using the split subpaths tool. I'm going to sort of splice it, and I'm going to then pair the spliced paths with their corresponding circle using this pair subpaths tool that Rebecca used yesterday. And then finally, I don't have the same number of points in those middle shapes, so I'm going to add 3 points to that middle circle up there. It's outlining it in red because it's not compatible and doesn't know how to morph them, but I can add dummy points to this circle in a way that the animation will look okay. And now everything's blue, everything will run at runtime and won't crash, and I'll get something like this. You can further customize this by adding a little rotation. I find that adding rotation to path morphing animations kind of distracts the eye from the actual morphing between shapes and makes stuff look a lot more seamless. So I'm going to set the pivot to 1212, and I'm going to add a 360-degree rotation animation using this little drop-down menu. I'm going to create a little animation block, and I'm going to customize it in that top right panel, and you'll see what it looks like right now. Yes, cool. Yeah, so again, this is basically what I designed Shapeshifter for, to easily create these animations. It's really useful to if you just pick 2 arbitrary icons and sort of figure out ways to morph them together. I mean, I have fun doing it, at least. And it makes the app look really great. And then this is what it looks like when you export it using Shapeshifter. It's a bunch of gibberish, basically, but you don't have to care about that. You just have to copy it into your resources file and then reference it in code. And this is all at shapeshifter.design. And I'll tweet some links to previous talks I gave about this that will go into a little more depth.
Thank you, Alex, for that tool. It's awesome. So our goal today was that you all understand what we know about vectors, and as such, you go forth and use them in your applications. Hopefully, we've convinced you that vectors are sharp, small, and support things like animation or tinting or color state lists and all this good stuff. And you've seen that the format is pretty powerful, and you understand a bit more about it. So now that you know its capabilities and some of the tooling that can help you, hopefully you can find a way to work it into your workflow with your designers and use vector assets pretty much everywhere. Thanks very much.